All right, so I wanted to go through these notes with you so that you're ready for school or ready for class. And and quite honestly, if you watch these videos ahead of time, then it just means that you're going to be able to process it a little bit better so that when you're in class and we're going over these notes, things make more sense to you. It always makes more sense the second time than it does the first time. Maybe you'll be able to answer a question. Maybe you'll be able to say, oh, that's why we did that. Okay, that makes more sense now. So let's dive into this. Ha ha ha, that's a great joke. A diver is going through ocean search and rescue training. The graph below shows the relationship between the diver's depth and the time in seconds since starting their dive. So, what details can you determine about the dive from the coordinates of the point? After 5 seconds, the diver is 8 feet below the surface. Um, so that's what that point is trying to tell us. When you get to the second part, it says, what's the average speed? Well, he went 8 feet in 4 seconds. Now you're saying, why 4 seconds? Well, I would say 8, because in the water, I mean, is this part up here really important as you're diving in the water? Because you're in air. That's different. Once you hit the water, you're 4 seconds is what we're talking about. Actually, I marked the wrong one, but it is 4 seconds. And we traveled 8 feet underwater in 4 seconds. So the key thing was in the water. So I can't include that first few feet because you were above the water surface. When you get down to part C, which point of the graph shows the starting point location of the diver? Obviously, that's the point 02. The diver was 2 feet above the water level at time 0. That's what they mean by explanation. And because you got to know what the time means and what the distance means. Since it's positive, that's 2 feet above the surface of the water. What does the V shape of the graph tell you about the dive? The V shape tells us that they went down and back up. It doesn't absolutely mean the speed down and back is the same. That's, you look at the slopes of the lines. In this case, that is the truth, but they don't have to be. Now, it also says what information does it not tell you about the dive. This picture, do not think that this picture tells you that he actually was diving in a V-shaped pattern. We are just measuring depth and time. Because we put it on a graph where we put the depth on the vertical axis and the time on the horizontal, it looks like he went at this angle and then came back up at this angle. But that's not really, he literally could have gone straight down in the water and straight back up. It's because we stretched it out over time. That's why, but people get in their mind, okay, well, that must be the path of the dive. And I'm like, no, that's not necessarily the case. It doesn't tell me the position. Next slide. So interval notation and inequality notation. So you're probably very familiar with these kind of things, For instance, that's a closed dot, so that would be a parenthesis. That's or a bracket, whereas an open dot would be a parenthesis. Over here is obviously it's going higher and higher and higher on this end. Same thing here. And that's where we get infinity from. And notice that there's always a parenthesis on infinity, or in this case, when we're going to the left here and here, on negative infinity. Never, ever, ever do you have a bracket on infinity or negative infinity. So, and I want you to always get in mind, smallest on the left, largest on the right, every single time. Smallest on the left, largest on the right. So negative infinity is actually smaller than 3. It's also smaller than positive 1. So that's why on these intervals right here, you have negative infinity 3 and negative infinity 1. Whereas the smallest values on the left, the largest values on the right. Okay? So that interval notation, bracket means closed, parenthesis means open. Of course, the inequality notation is probably the one you're more familiar with. Greater than or equal to, greater than, less than or equal to, less than. Then we talk about these things right here. Domain, those are possible x values. And I actually think this part of the slide is supposed to be on the next one, but for some reason I got it cut wrong. But domain is possible x values. Range is possible y values. And then just as a reminder here, if something is a function, we use what's called the vertical line test. And I know that a lot of middle schoolers get told it's the pencil test. And I get it, you're passing a pencil through the graph. You're basically holding up a vertical line and you're crossing it through the graph to see if it crosses only one point at a time. If it crosses 2 points at a time, then we say it fails the vertical line test and it is not a function. So let's see some examples on the next page. We've got to find domain, we've got to find range. So, here are 3 pictures. The first 2 pass the vertical line test. Because you pass that vertical line through the graph, you start drawing all those vertical lines through the graph. It only hits 1 point at a time. But when you get to this one over here, boom, right there, it's a fail. So we know that the circle on the far right is not a function. It fails the vertical line test. But the first 2 pass the vertical line test. We wrote out the domain and range. Now, I've got to give you a little bit more of a picture of domain and range so you actually understand this. So let me pause the video for a second. So I've drawn out a picture using desmos.com /calculator. It's the graphing calculator version of Desmos. Maybe I should type that out on screen. Desmos.com /calculator. You do not need a graphing calculator. It's optional for Algebra 2, so don't think you have to have one. But I can show you how to do it on the graphing calculator. But currently I'm at home, so I don't have my camera, so we would use the y equals feature and type in our equation. But you don't really need it for this question, but I do want to show you digitally so that we can kind of understand what's going on here. So what I'm about to do is take my picture over here and on the right, and I'm going to take my 2 fingers and I'm going to grab the y-axis. So I've got 2 fingers on the y-axis. It's turning light blue right now. And now I'm squeezing them together. And what I'm doing is I am basically flattening the graph. I'm doing basically a scale change in the vertical direction only. And as I flatten this graph, my question to you is this: how much of the x-axis got covered by something? Now, I would hope you would say the entire thing. All of it. The entire x-axis. And that's why the possible x's go from negative infinity on the far left to positive infinity on the far right. Now, if we look at that graph again, but this time we collapse on the y-axis. So I'm crushing the graph in the y direction and asking you how much of the y-axis got covered. Hopefully you can see that it starts down here at -4 and it just keeps getting higher and higher and higher. Now, since that does have a stopping point down here at -4, it must equal that, and that's why the bracket comes into play. And it goes from -4 up to positive infinity. It just keeps getting higher and higher and higher. So let's look at the next graph. Okay, we've got our next equation. Okay, and we're going to do the same thing. Smash it onto the x-axis, how much of the x-axis got covered. And as you can see, it looks like the entire thing. So that means negative infinity to positive infinity for the domain. Now we'll come back to the range, and we'll smash it onto the y-axis. And when we do that, we can see that the highest value here is 3, and it goes down to negative infinity. Of course, we always want the smallest value to be on the left. That would be negative infinity in this case, and the largest value on the right, which would be 3. Since it does max out at 3, we have to include it with the bracket. On the next one, I'm hoping it's fairly self-explanatory. That, let's see here, we'll do that, and do a little zoom in on this to look at this picture. And hopefully you can see that it goes from -2 on the left to +6 on the right, and from -5 on the bottom to +3 on the top. And it includes those values on the endpoints, which is why they have to have the brackets. So these other ones they stop. They have stopping points. So it's not like I can graph them on Desmos so very easily. Now, when you take a look at this, this is open. And since that's open, that's going to have a parenthesis. That's why you get this parenthesis right here, going from -5 all the way over to +4. But because that's closed, that's why we have to have that bracket on the end. Now, when you get to range and you do that whole collapsing on the y-axis, you're going to have a value down here at -2, and you're going to have a value up here at +4. And closed on both ends. On the domain of the next one, we go from -4, bracket, all the way over to +5. Now we are putting a bracket right there, and it's because of this one right here. The one at the bottom does not include it, but the one at the top does. So you must include the 5 at the end of that domain. And then for range, we're doing -2 to +4. But it does not include the -2 because it's open. It is closed at the top, so that it does include the +4. Domain, we're going from -6 all the way over to 3, but did not include the 3 because the 3 is open. Now on this next one, the tricky part right here is that the -5 is included on the left side. Yeah, I know it's not included on the right side, but it is included on the left. And of course, it's included at the top twice, basically. So that's why both of those are closed. Remember to pause your video every time you get to a point where if I go too fast and you're trying to write things down, always pause it and, or rewind it, look at it, see what you need to get written down. And that's only for you if you are, now if you want to take the notes ahead of time before we get to class and you want to have them all written down, please don't ignore me in class. That's not the goal here. I do not want to be ignored because, hopefully if you're watching this ahead of time, your goal is to see it twice. Once in video format and then once when we're going over things so that you can be a part of the class and it makes more sense to you. Okay. Story problem time. Air tanker flies over forest fires and drops water at a constant rate of 400 gallons per second until its tank is empty. Tank holds 8,000 gallons of water when it's full. So we know right away from that information that 8,000 is where we're starting. Okay. And so we've got 8,000 gallons to start with. We are losing. And so that's telling me that we're going down 400 gallons per second. So obviously this is in seconds, not minutes, or any other time equivalent, unit. Write an equation for the situation where y is the volume of water left in the tank after x seconds. So we've got it right here. We've got 8,000 to start with, and we're losing 400 every second. When they say per second, that's your slope. So we do have a slope of negative 400. Where does the graph intersect the x-axis? Well, we know where it intersects the y-axis, but the x-axis, that's where you have a y value of 0. And so then you start solving that equation. And of course, I moved the 400x over to the other side, made it positive, and then divided by 400. It would still work if you subtracted 8,000 and then divided by negative 400. You'd still get 20 seconds. So in 20 seconds of time, we have dumped all the water. So that's why we had that point right there. And then, of course, this is a linear time frame because we're dropping the same amount of water every second. So you're going from 8,000, and in 20 seconds, you're going straight to 0. So that's why I connected them together. Domain, remember, smallest on the left, largest on the right. So if you're looking at this from, if you smashed it all onto the x-axis, 0 to 20 would be your domain. If you smashed it all on the y-axis, it would go from 0 to 8,000. Smallest on the left, largest on the right. And that's our notes for today. So make sure you ask questions in class if things do not make sense. That's the whole point, is to make sure that this makes sense to you so you can get going on the homework. Talk to you soon.